This is the first program in Lab 5. Make sure you filled in title, author, date, and description. I'm just going to scroll up a little bit here so we can see most of our code, and then I'm going to hit F5 to actually run our program. Now I'm going to slide this a little bit over to the right, and let's take a look at our code. It's doing system clear screen, value equals 1, x underscore ptr equals ampersand value, printf, and then a system pause, which brings us down to press any key to continue, which is our system pause command. Now it's going to do, if we take a look at here, we have a number of system pauses, so I'm just going to hit over here, enter again, and again. So what we have here is 4 sections of output that's been generated here, and what I want to do is then save this output in our program as a comment. To do that, I'm just going to hold down the left mouse button, select all of this out here, go up to our top bar, right mouse click, go down to edit, and select copy. Once I do that, I'm going to click on this screen again, slide down here to the very bottom, put a /*, enter, go up a line, and do Control V. And at this point, what we have is our program output saved as a series of comments after our program. And that's what we're going to need to be able to analyze pointers and understand exactly what's going on. Lab 5 is to do with pointers, and for pointers we really have to understand how addresses, physical addresses and symbolic addresses work. Now what we have over here is a printout that we got from our program, and the printout here associates physical addresses to variable names. But every time you run it, it's going to associate different addresses to the variable names, but the pattern that you'll see will be the same. Let's take a look over here. We have a C statement, value equals 1. The symbolic address here is just value. Now the concept of a symbolic address is it's a label for a physical address in memory. So right now value, if we look over here, has address value as given here. Now each address value, this is a hex address value, it should have 8 digits, this one has 7, so we'll just flesh it out with 1 extra digit. So I'm just going to be lazy and I'm just going to go here and I'm going to copy this and I'm going to paste it in here, but I'm also going to have to put a leading 0x0. So this is the physical address that we've got for this value. So right at the hardware level, this address and value are identical. This is what we use, but it really refers to a physical address in memory that will change every time we run it, but in this particular time we run it, this address and value are synonymous. So what you're going to see is value equals 1, which means value is going to have the value 1 here, but it really means at the hardware level that this physical address will get the value 1. And that's an important concept that we're going to have to understand. Now saying that value equals 1 means that you're directly putting 1 into a physical location in memory, which can be referenced by this symbolic address. Now that's how we do it directly. 1 goes into here. Very simple concept. But there's other ways to actually manipulate what is happening at this physical address, and that's using pointers. This is indirect and it takes a little while to get used to. Now when you take a look at x underscore ptr equals ampersand value, x underscore ptr has been defined as a pointer. Pointers contain address values. They don't contain data values. Value is a regular variable. It contains a data value 1. X underscore ptr has been defined as a pointer, so it's going to contain an address value, and the address value it's going to contain is the same as the value of the address for value. So let's take a look here. This is going to be, if we look here, the symbolic address is x underscore ptr, and what is it going to contain? It's going to contain exactly this as its contents, but it's going to contain that as 2 digits at a time. So this is 0x01. The next address is going to be 0x12. The next address is going to be 0xf8. And the last address is going to be 0x93. So x underscore ptr contains the address value 0112f893, which means it contains the same as this. So this, which is containing an address value, this contains a data value, but this is the address of where this data exists, which is 1. Now that's a strange concept to get your head around, but this address here and this, which is contained in the pointer, are identical, the address being referenced here. If you say star xptr, that means the value at the x pointer, or the value at the address, which is the value here, is now going to be 2, which means this address is now, instead of having 1, will be given the value 2. And this is an indirect way of doing things. So what address is going to get that? If we take a look, this address is going to get the value 2. Because this says the value of the address at the x pointer, which is this, is going to get a 2. So instead of being 1, it will now be 2 at this point. Now before we continue on, let's take a look at the actual address of x pointer itself, because it's in a separate set of 4 addresses. So it says the value stored is this, which is what we've got, but it also says the address of the x pointer is this number. So this number is 0x 01 12 F8 F8 9C. Now that's going to contain the 1, and the next address, because I'm lazy, I'm just going to copy this and paste it, and this will be the next address after C, which is D, because we're counting in hex. Let's copy this, and this is address the same but E, and again, being lazy, let's copy this and paste it in here and make this an F. So the pointer contains an address, and an address is going to be 8 digits, 2 per address. So the pointer is going to take up 4 addresses in memory, and each address is going to contain 2 digits of the actual address of what it's pointing to here. Let's go back and take a look at this again. Value is really a symbol for a physical address in memory. That physical address in memory is going to get the value 1. Let's take a look at this next statement where it says the value in the x pointer, which is the same address as value is a symbol for, is now going to get the value 2. So value is going to get the value 2. Then you have value equals test function of value. Now value is going to have the value 2, and you're passing a 2 in here. Now notice that these two symbols are not the same. This is a bucket called value, which has got a value 2, and it dumps its number 2 into here, and then it says, okay, whatever comes in, you're going to multiply that by 2, so 2 times 2 is 4, and then you're going to return that back up to here. So value at this point will be 4, and you've learned about functions in PRG1. But what's really strange is this statement here. What it's doing is this is passing in not a data value, but an address value to here. And what this is really saying is the address contained in value 2, which is really the physical address that value has, is going to get 2 times what was previously in that physical address. So it came in with 4, 2 times 4 is 8, so the address, the physical address that value has, is now going to have the value 8. So if we follow this through, value equals 1, value is 2, value is 4, and finally value is 8. So it does make a little bit of sense, but you're really going to have to work with it. Let's take a look at the lab itself. Now you can see here it says passes the address of variable value into function test function 2 as value 2. So what is it passing in? It's passing this in. So all we have to do is put this value here, because this is the physical address. If we look up here, because this is a physical address of variable value. So as I said, this is an indirect way of dealing with this. The physical address of value is going to be then modified to get the value 8 as it shows here. Now you might have to go through this a few times, but the important thing is that you're able to fill in these numbers here correctly based on what you've got here as your printout. And I will be checking to make sure that these numbers that are here the specific ones you've used, are used properly in here.